Imagine we have a right triangle, and I'll call my right triangle's legs A and B, and I'll call the hypotenuse H. And at a given moment in time, A happens to be 30, and B happens to be 0, or I'm sorry, B happens to be 40, and this is the case when t, or when time, is 0, right? We're just starting out, and they start off at sizes of 30 and 40, respectively, but they're going to change. And some things we know about this triangle is that its area would be equal to 1/2 A times B, because A would be the base and B would be the height. And we also know that to find the hypotenuse would be related to the hypotenuse squared must equal A squared plus B squared by the Pythagorean theorem. And if we needed expressions or wanted expressions for how the area is changing, well then dA dt by the power rule would be equal to 1/2 dA dt, d little a dt, times b plus 1/2 a times dB dt. And if we wanted an expression for the rate of change of the hypotenuse, then dH dt, how the hypotenuse is changing, actually it's h squared in our expression, so to find the derivative of h squared, it would be 2h dH dt would be equal to 2a dA dt plus 2b dB dt. And when we solve this equation for dH dt, the rate of change of the hypotenuse, by dividing both sides by 2h, we would end up with a times dB dt plus b times dA dt all over h, because the 2's divided out. So we have expressions for our area and our hypotenuse, and we have an expression for dA dt, the rate of change of the area, and dH dt, the rate of change of the hypotenuse. Now we can be given some specifics. So example A tells us that specifically the short side in our case is A, so dA dt is increasing by 3 inches per second. And we're told that the long side is also increasing, dB dt, at 5 inches per second. And the question is, what's the change of the area and what's the change of the hypotenuse? So what we want to know is, what is dA, the big A, dt, the rate of change of the area? Well, at this specific moment in time, we know that A is 30 and B is 40. So using our formula that we've solved for, the rate of change of the area must be equal to 1/2 times dA dt, which we're told is 3, times the length of B, which we're also told is 40, plus 1/2 times A, which is 30, times dB dt, which is 5, which is 60 plus 75, or a total of 135 square inches per second. That's the rate of change of the area at that moment in time. The second part of the question is, what is the change in the hypotenuse? So what we want to know is, what is dH dt? And we know that dH dt is equal to A, which in this case is 30, times dB dt, which we're told is 5, plus b, which in this case is 40, times dA dt, which we're told is 3, and all of that is divided by h, or the length of the hypotenuse. Well, when a is 30 and b is 40, we need to figure out what the hypotenuse is at that time, and we're just using the Pythagorean theorem to do that because it's a right triangle. And when we solve this for h, we'll find that it's 50, and perhaps you recognize this as a Pythagorean triple. So we know that when the side lengths are 30 and 40, the hypotenuse must be 50. And as we simplify this, what we'll find is that dH dt is equal to 27 fifths, and since this is a length, it would be inches per second, or we could say it's 5.4 inches per second. That's how much the hypotenuse is changing under those circumstances. Let's consider example B is a similar scenario, right? We've got the same triangle, but this time the changes are different. This time we're told that the short side, so dA dt, is increasing at 3 inches per second. But we're also told that the long side, so in this case dB dt, is decreasing at 5 inches per second. So since it's decreasing, it would need to be negative. And we want to know the change of area and the change of the hypotenuse. So again, dA dt we know is equal to 1/2 dA dt, which in this case is 3, times b, which is 40, plus 1/2 times the length of a, which is 30, times dB dt, which is -5. And when we simplify this, this would be 60 minus 75, or -15 inches square inches per second. That's how much the area is changing. It's decreasing. For the next question, we want to know the change in the hypotenuse given these circumstances. So we know that this would be 2 this would be A, so in this case that's 30 times dB dt, which is -5, plus 40 times dA dt, which is 3, all over h, which we already know is 50. Which means that the change in the hypotenuse will end up being -30 over 50, or -3/5 inches per second. In the next video, we'll consider some more related rates.